So guys, yes guys, do you actually ever wonder how do you receive these TV signals, how do you get these refreshments, and how you are able to watch the different channels live at your home? Let's learn all about the satellite TV working and the parabolic reflectors in this particular video.
Now the first thing you have is the program shows, like any channel you can imagine, like Star or Z or Aaj Tak, CNN, NDTV. They are basically having the video production facility. They are providing the content throughout, that is 24/7, either in the live format or in the recorded format. To give you a better understanding of the program shows, let's go outside.
So yes guys, as we were discussing about the program shows, so just to show you and give you the feel, I've come to the India Today broadcast center, just available just as you're able to see in front of you. And let us also go to the other side of the building where I'll show you the transmitter antenna. So now I have come to the other side of the India TV building, and as you're able to see, that is the transmitter installed there. Let's once again go back to the studio and continue our discussion.
Now, having understood program source, let's continue our discussion forward. So the content produced by this channel or the program source has to be available onto the various satellite TV broadcasters, which we usually call it as the DBS providers. For example, Tata Sky, Dish TV, or you can take Airtel, Jio Fiber, lots of DBS providers. So the information, the video produced by this channel has to be available to all of these different DBS providers. Now for this, let's have a look into this. For this, the program's source is going to transmit their signal onto the transponder which it has rented, and that transponder is in the geostationary orbit. Right now, the complete information that is given by the program source is now available at a single point, and any DBS provider, be it Tata Sky or Dish or etc., can access to this information by its respective receiving antenna. But before that, it has to make an agreement with the corresponding channel. Okay, so now that we can say that the DBS provider has collected the information, collected the video, the content from the program source, and similarly this DBS provider can collect the information or collect the content from different program channels, right? You have let's say 400 to 500 approximately channels available on any DBS provider. Now that the DBS provider collects the information or the videos from the program source, that is the channel, the DBS provider already has its own broadcast center where they need to do video optimization, like MPG compression. They need to standardize the bit rates, they need to encrypt the video for the privacy purposes. So after all these video optimization inside the broadcast center, the DBS provider will now be ready to send the signal to its own transponder. And not only one, every DBS provider will have multiple transponders, rented transponders, because they have the collection of huge amount of data. And once they transmit the signal through their own transponder, now it's the turn for end user, right, like me or you, to receive the signal. Yes, for us to receive the signal from Tata Sky or Dish TV or etc., we need to install the corresponding antenna. Yes, that is known as the parabolic dish receiving antenna. Yes, but the very important point is the antenna that you install, maybe on the terrace or maybe on the balcony, has to be phased, has to be angled in a direction corresponding to the transponder, right? You can feel that. You can just go out, guys, and check it out. As a simple fact I'm telling, go to your locality, right, and you may find one Dish TV antenna, one Tata Sky antenna, one Airtel antenna, reflector, the receiving antenna I'm talking about. Within the same location or same locality, they may be angled differently, they may be positioned differently, something like this, because every parabolic receiving antenna has to be angled in a direction corresponding to its transponder, corresponding to the transponder of that particular DBS provider. So you can just check out that outside. Okay, now we'll talk more about this. Yes, I'll clearly going to show you what this parabolic reflector is, what are the different components of the parabolic reflector, and how does it actually function. So once, we'll go to that also, but once the signal has been received by the parabolic reflector, the parabolic reflector is finally connected via a coaxial cable to the setup box. Yes, if you have the Dish TV connection, you'll be having a setup box. Yes, now in the setup box, the videos that were encrypted by the DBS provider will be actually decrypted here for it to be received by the end user, and now you're then finally watching the videos successfully, enjoying watching the TV. Right now, what does this particular mechanism contains? What is there in the parabolic reflector? Right, what is this feed antenna? Let's go and learn something about that.
So yes guys, in this video we are going to talk about the working principle of the parabolic reflector reflector antenna, how this reflector accumulates the electromagnetic energy and focuses it on the single feed. What is the role of the feed? What is LNBF and what are the different parts of it? Let's learn part by part and let's clear all our concepts regarding to this dish TV antenna. Stay tuned with me again.
So this is basically the support structure of this reflector, where this long pole is commonly known as the mast. This is the parabolic reflector, yes, the dish reflector, as you're able to see. This is basically the arm supporting the LNBF, the LNBM arm. This is the LNBF holder, and here we have the LNBF, the low noise block down converter with the feed horn. Yes, I'm also going to talk about the internals of it. How does it actually, gathers the electromagnetic energy?
So from one of the antenna which was not operational, I have got this LNBF also to show you the internals of it. So this is the low noise block down converter with the feed horn. Let's come closer to it and watch into it.
So at the front you are able to see the horn antenna connected to the waveguide, finally to the probe, as you are able to see inside the probe is connected, right? The probe then transfers or sends the signal to the PCB, which is inside this particular module. The PCB is basically for signal processing, that is the amplification of the signal, filtering out the unwanted frequencies, and then the final signal has to be transmitted to the television unit, and that is transmitted via a transmission line. So this is the outlet unit for the coaxial cable. Yes, here the coaxial cable is connected, and that coaxial cable is finally connected to your setup box, which you have connected with the TV units.
So I hope you have enjoyed watching the parabolic reflector with its different components, the dish, the LNBF, the internals of it, right? This picture again shows a parabolic dish, how it is able to capture the electromagnetic energy and focuses on a single feed, right? So guys, a very simple query here right now, right? At the feed point, why do we use the horn antenna? Why not the dipole antennas, which are very simple and commonly available? So a simple idea to this is, assume that you have a tube light, right? The dipole antennas, the wire antennas, which are, nearly isotropic in nature, they radiate in all directions. Suppose if you have a tube light, if this is a tube light, right? Where will be the energy, where will be the light from the tube light transmitted? It's going to be transmitted everywhere across it, right? We don't need the transmission everywhere across it. Rather than that, we need the focused transmission, highly directed transmission, something like torches. So I don't have the torch right now, but yeah, if I just turn on the torch of my mobile also, when you turn on any particular torch, right, it is sending out a directed beam of light, right? It is not radiating all around it, but it is only sending a specific beam of light. So that is why these days we don't use the dipole antennas, we use the horn antennas, as I have shown you already, the LNBF, which is horn antenna, right? And the signal through the horn antenna and waveguide is reaching the probe, and the probe converts the signals, the EM energy, into the voltage signals. The voltage signals reaches the PCB, right, where the filtration process and all the signal processing part is done, and finally that processed signal, the processed voltage signal, is transmitted to your internal TV setup box via the coaxial cable, as shown in this picture as well, right? A small animation once again, the electromagnetic energy, the beam of electromagnetic energy falling on the reflector, and this reflector, the task of the reflector is to accumulate all the energy towards this feed horn, But you might be able to see very clearly, that in this previous picture, I have taken the feed at the center, whereas in this picture and the actual picture, the actual reflector that we have seen, the outside reflector, even there the feed was not exactly at the center, but it was somewhere downside. This is known as an offside feed. I shall explain you the reason behind this. So let's go through some advantages and let's understand the reasons also. So a parabolic reflector can be used both as a transmitting and receiving antenna, although we are discussing right now with receiving antenna, but there is the transmitting and receiving antenna both possibility. Now feed can be in various modes, that is the center, Cassegrain, and the offside feed. One of the major advantages of the parabolic reflector is the high directivity. As I'm showing you, it is more directed, right, in one particular direction, high gain in one particular direction, and it also has an increased capture area, right? Because if the electromagnetic energy were to directly fall on the antenna feed, right, that feed is very small, right? This particular dish basically is doing one more task, that is, it is increasing the total capture area, and because of the increased capture area, we'll see the increased directivity, the increased gain also. Now, what is this offside feed, right? So guys, whenever you connect the feed at the center, what is potentially happening? Let us understand what is potentially happening. let us learn through a small picture. Suppose this is the parabolic dish, right? And you connect the feed exactly at the center, right? Then what possibility is there? What possibility is there? This feed connected at the center, whenever the electromagnetic energy is falling over the reflector, a part of the electromagnetic energy itself is being blocked, because this is a small, but this is also not a very small structure. It cannot be neglected. So it is actually, when it is coming in the center, it is a major blockage. It is a major blockage to the electromagnetic radiation. That is why usually we take in the receiving antenna, we take it as the offside feed, which is where it is shifted a little bit downwards, and then the electromagnetic energy falls over the over maximum of the entire plate, and then it is concentrated towards the horn antenna, right? Why horn antenna? Why not dipole? That also we have discussed. But before going forward, understanding the gains and all, let us also learn about some of the disadvantages. And as I've told you, the feed antenna is going to block 1 to 2. So even though if you take the offside feed also, definitely it may be blocking less than what the center feed is blocking, but still it is there somewhere in the path of the EM energy, and it is going to block some radiation. That is one of the disadvantage of the parabolic reflector, right? And one more very important point, right? Definitely you use a feed horn. You are not using the dipole, right? You expect uniform illumination, but certain amount of power from the feed is bound to slop over the edges of parabolic reflector. Let's understand something like this before going to the gain. Part, right? So suppose if this is where, even if you take the offside feed case and this is where the feed is, right, and assume this is with respect to mostly the transmitter antenna as well, when this is acting as a transmitting antenna, some amount of power, right, is going to go outside the curvature of the dish. Okay, it is going to slop over the edges of the parabolic reflector. That is also one of the disadvantages of the parabolic reflector. And in order to achieve, now one more important point, in order to achieve the best performance, the feed should be placed exactly at the focus, but this is usually practically not possible. Now, where do the feed is placed? What is the distance of the feed from the center? That ratios also I will give you a little practical idea where exactly they are placed. But let us talk about the gain of the parabolic reflector. The gain of the parabolic reflector is commonly calculated and related with the effective area constant, where the effective area is lambda square by 4 pi into the GD. The lambda square by 4 pi into the GD, where GD is the gain. Now let's consider the maximum effective area. When you consider the maximum effective area, this can be represented as the directivity. So what is the directivity? It becomes 4 pi by lambda square effective area, and then we have the concept of aperture efficiency. All these terminology you will learn if you have studied the antenna, or if you are going to study the antenna for the GATE preparation, right? And there is a common question also coming up from the effective area and the directivity. Is a very common question. So we use a term of aperture efficiency, and the aperture efficiency is basically the effective area, right? The effective area, the maximum effective area, right? Because I've used the directivity, I can say the maximum effective area divided by the total maximum physical area possible, right? So if I want to write down the AE, what will be the directivity now looking like? The directivity will now become 4 pi divided by lambda square into eta, right? I want to write AE, the eta into the physical area. So what is the total physical maximum area here? What is the total maximum physical area in case of a parabolic reflector, right? So let's say D is the diameter of the dish and R is the radius of the dish. So then the area can be computed as pi R square, where R is the half of the diameter. Let us put down commonly in terms of diameter only. Okay, let me use the small d here, because D I have called it as the directivity itself. So let me rename it. Let's say this is equal to D. Okay, so the directivity now becomes 4 pi by lambda square eta, and this was pi R square, where I is equal to the D by 2 whole square. So 4 will get cancelled. Directivity will be coming up as, this pi is missed, sorry. So it becomes the pi square, 4 is cancelled, pi square upon lambda square into eta A into diameter square, or this is, separate out the efficiency, it becomes pi d by lambda whole square. It becomes pi d by lambda whole square. The value of pi The value of pi square is approximately 10. So approximately I can write down this result. Approximately I can write down this result as 10 into efficiency, aperture efficiency into D is divided by the lambda whole square, where this efficiency is commonly in the range of, for most of the practical reflectors, this is commonly in the range of 0.5 to 0.6, 0.60, that is 65% is the maximum efficiency possible, the maximum aperture efficiency possible. So even if I take the max value, even if I'm considering the max value of 0.6, the parabolic reflector designed at its maximum efficiency, that is going to have a gain equal to 10 into 0.6, that becomes 6 d by lambda whole square. That is giving you a very clear message that the directivity of the antenna is clearly proportional to the square of the diameter. This is also clearly giving you a message that the larger the capture area, the larger is the dish, more will be the directivity. Right? But you cannot blindly increase the diameter, because you also have to take care about the point where the feed has to be placed. So what is the F by D ratio? F by D, let's call it as small d only, right? The same terminology that I have used in the last slide. Let us calculate the F by D ratio. Now, what is the role of this F by D ratio? Right, the point where the feed is placed and the total diameter of the dish. So, just understand through these two pictures. So, suppose this is what is your dish, and this is the point where you place the feed, right? You take a feed far away. You take the feed far away. Okay, so case number 1, where the F by D ratio is much greater than 1, right? It's a far away. So then what happens? Okay, a lot of the electromagnetic energy is going to go outside this. So anyways, this is a disadvantage we have already understood. Okay, this is already one of the disadvantages that I explained you, that there is some power from the feed that is bound to slop over the edges. Right, but if we use the proper F by D ratio, we can minimize this slopping, right? So there is a lot of power that is slopping over the edges. On the other hand, if you use a very small F by D ratio, suppose you place your feed somewhere at this point, right? Suppose F by D is a much small quantity, then what is going to happen? Then the electromagnetic energy radiated by it is going to fall over only a very small portion of this reflector. It is going to fall over only a very small portion of the reflector, isn't it, guys? It is going to fall over only a very small portion of the reflector, so it cannot be very small. So what is that optimum value? What is that optimum value? Let us understand that. So there is a formula for that optimum value. There is a formula for that optimum value. So suppose, let's say this is the point where the feed is placed. Okay, we shall calculate the angle, the highest angle that it makes with the edges, with the boundary of the reflector. Iska zarurat nahi hai. Let's remove this. Let's say that angle is equal to theta, and then we determine the F by D as 1/4 tan theta by 2. Now, even if you place it exactly at the center, the theta would be 90 degree. If you place it exactly at the center, just at the opening of the dish, and exactly at the center, theta would be going to 90 degree, and making the theta 90 degree, 90 by 2 is 45 degree, tan 45 is 1, and this will be 0.25. Okay, what is the practical range for F by D? Okay, so if you take the theta equal to 90, then you get the F by D as nearly 0.25. The optimum range of this is, just practical values to inform you, the optimum range of it is somewhere from 0.2 to 0.5. This is considered as a good design ratio. This is considered to be a good F by D ratio. This is considered to be a good F by D ratio, right? Regarding to the offset feed, I have already explained you why do we provide the feed in the offset. Okay, why don't we take the feed at the center rather than the center? Because if you take the feed exactly at the center, it is going to block a considerable portion of the electromagnetic energy, and that is why commonly we take the feed Commonly we take the feed, little bit of the downside, okay, so that the electromagnetic energy, as I've shown you in the animation also, falls over the maximum area of the reflector, and then that reflector, the role of the reflector is once again to concentrate all that energy, on the feed. And as we have already understood that this feed is connected by the support mechanism of the LNBF arm, right? This was the LNBF arm, right? So once again guys, even if the feed at center, the LNBM arm will also come to the center, na? Agar feed ko center mein connect kiya, then the arm also coming to the center, and that is also responsible to block a portion of the radiation, right? That is why we normally provide a offset feed, right? This is what already I explained you. Okay, so I hope you have understood everything regarding to this process in this small video, where I've tried to explain you how the signal transmit from the program source. It reaches the transponder, which the program source has rented out. That transponder is available in the geostationary orbit. So the signal, the information of a particular channel, one program source is like one channel, you can imagine NDTV or etc. It is available at one single point. Now the DBS provider can make an agreement with that particular channel and collect its information, and then that information is processed within the DBS provider. They have the broadcast center where they do the video optimization, and after the optimization of the video, they finally send the video to their own transponder, where they have several of transponders rented out because they have huge amount of data. And now the end user can finally receive this signal by installing the dish TV receiving antenna at their terrace or balcony, but that antenna has to be facing this particular transponder direction. Okay, and then what are the different components of this particular antenna, what is the LNBF, also I have explained you. So hope you have liked this, hope you have this develops the interest in antenna. Guys, this is a very small description of antenna. So once we go very deep into antenna, there are thousands of concepts to study, right? So that is why, this can also be one more motivation to prepare for GATE, because anytime you prepare for GATE, you prepare a topic very conceptually. So you go inside the antenna, start learning all basics of antenna, and definitely antenna is one of the very, very expected topic in the GATE examination. So guys, hope once again you have liked the video. Small request, do not forget to mention how did you like the video in the comment box, because I've done a lot of effort, going to the program center also physically, making the video in front of a physical reflector, taking out the LNBF out of it, explaining you the different parts of the LNBF. So there has been a lot of effort involved from my side. Just do mention in the comment box how you liked the effort and how you actually like the content. One is about the effort, one is about the content. Okay guys, bye bye, thank you, stay safe. Keep subscribed to the BYJU'S Exam Prep GATE YouTube English channel to get more such videos and more such informations. Bye bye, thank you, stay safe and take care of yourself.